Enjoy the journey of learning with Anil Kumar. Question number 16, where we're looking into domain and range of a composite function. If f of x equals to log to the base 2 of 8 and g of x is 4 minus square root of x plus 2, h of x equals to f times g of x, find domain and range of h of x. So let's write down what is given to us. We are given f of x equals to log to the base 2 of 8. G of x is 4 minus square root x plus 2. And h of x is the product of functions, right? So h of x can be written as f of x literally is a constant. When we write log to the base 2 of 8, it means what? It means log to the base 2 of 2 cubed, right? Which is 3. So f of x is constant 3. So we can multiply 3 with g of x. G of x is 4 minus square root of x plus 2. Correct? So that is what h of x is. So we have h of x. Let's write down clearly. Rearrange the terms. Open the brackets. So 12 minus 3 square root of x plus 2. More familiar way, we'll write square root of x plus 2 first and then 12. Clear? So from here, we get our domain and range. So as far as the domain is concerned, we can write down domain as x plus 2 should be greater than equal to 0, and that gives us x is greater than equal to minus 2, right? So we can write domain as x belongs to real numbers where x is greater than equal to minus 2. Clear? Now let's look into the range. Now range of this function, the square root function has been reflected on the x-axis, right? So the graph of this function will be kind of like this, right? And it has moved 12 units up, and therefore the range is y belongs to real numbers where y is less than equal to 12. Perfect. So that is how we are going to find domain range of this composite function. I hope the concept is absolutely clear. We have a composite function. We'll try to understand how do we relate these functions. It is part of our test paper on advanced functions. Question number 15. If f of x equals to 3 and g of x equals to log square root of x, find n where f times g of x is equal to log of x to the power of n. So in this question we are given that the function f of x is 3, g of x is log of square root of x, and another function is given to us which is f times g of x, and that is equal to log of x to the power of n. So here is a typing error. We missed square equals to, right, in between. So now that is a question for you. You can pause the video, find the value of n, right? We need to find the value of n. So to find the value of n, let's figure out what is f times g of x. So f times g of x, which is given to us as log of x to the power of n, f is 3 for us, right? So 3 times, literally you have to multiply. So you get log of square root of x, which is equal to log of x to the power of n. Apply the logarithmic laws, we could rewrite this as log of square root of x to the power of 3. That would be equal to log of x to the power of n. And with rational exponents, that is 3 by 2, right? And that gives you the result. Compare the exponents, right? This logarithmic equation. So we get our answer, n is equal to 3 by 2. So I hope that is absolutely clear. In this video, we are going to solve question number 14 of our test paper based on advanced functions, which is a prerequisite for calculus. The question is application of logarithmic functions. The question is, if the magnitude of two earthquakes is in the ratio of 5 to 3 on Richter scale, find the ratio of their intensity. So, for your ready reference, the formula which is used for relating intensity with the magnitude of earthquake is m equals to log I over I0. So let's begin with the formula itself, which is the magnitude is equal to log of I over I0. This logarithmic equation can be written in exponential form also. So we could also write this equation as base is 10, 10 to the power of m is equal to I over I0. Correct. So that is how the logarithmic and the exponential forms are related. Now we are given that the magnitude of two earthquakes is in the ratio of 5 to 3. So let's say one of them is 5, the other one is 3. So we are saying that magnitude m1 is 5, right? So in that case, 5 is equal to log of I1 over I0. And the magnitude of second one is 3. So magnitude of 2 is 3. So we can write this as 3 equals to log of I2 over I0. Correct. So working with logarithmic form, you can write like this. Now, let's relate them because we want to find the ratio of intensity, basically I1 over I2. So let's rewrite them into the exponential forms, correct? Use this formula which I have given you, right? So we can write I1 over I0 is 10 to the power of 5. And here, the intensity of the second one with a standard intensity is 10 to the power of 3. Perfect. Now, what is I1 over I2? So let's divide the first equation by the second equation. Simple as that, right? Let's move forward. And we will now write I1 over I0 divided by I2 over I0 equals to 10 to the power of 5 over 10 to the power of 3. Clear? So I0 cancel. And we get the ratio which is required, which is I1 over I2 is 10 to the power of 5 minus 3, which is 2. Correct? So that is the ratio, right? 100 is to 1. So we can write down the answer as I1 is 2, I2 equals to 100 is to 1. So that becomes the scale for intensity, right? So 5 is to 3. So you see the power of 10 is a logarithmic scale. So the difference of 2 is 10 to the power of 2 is 100 times intense, as you can see very clearly. So I hope this concept is also clear. And how do we use this formula in the right way is also very clear. Look into more videos on our topic and get ready for your final exams. Let us enjoy the journey of learning and mastering strategies. Here is question number 13 from our test paper of advanced functions, which is a prerequisite for calculus. It is based on application of logarithmic functions. A sample of lemon juice has a pH level of 4.5. Find its hydrogen ion concentration in moles per liter. pH level less than 7 means it is acidic, and hydrogen ion concentration is given in the units mole per liter. The formula for reference of our students is right there. So the pH level is equals to minus log of the concentration of hydrogen ions. So let's use this formula and find the answer. So we have pH level defined as equal to minus log of hydrogen ion concentration. pH level is given to us as 4.5. So 4.5 is minus log of hydrogen ion concentration. We can rearrange this equation. So minus, you could also write this as minus 4.5 equals to log of hydrogen ion concentration. Log is to the base 10, and therefore hydrogen ion concentration is equal to 10 to the power of minus 4.5. So we need to calculate this value. Let's use the calculator and find the value of 10 to the power of minus 4.5. So 10 exponent minus 4.5 gives us a value which is, so I'll write here, is equal to 3.1622. So I'll write 3.16 into 10 to the power of minus 5. And the units are mole per liter. So that becomes the hydrogen ion concentration for this acidic solution whose pH value is 4.5. So I hope you have understood how to use this formula and get the result. Feel free to ask for a PDF of our test question set for more practice. Master strategies and enjoy the journey of learning with Anil Kumar. Let us now look into the solution of question number 12 from our test paper on advanced functions. F of x equals to 5 over x plus 1 and g of x is 1 over x minus 2. You need to find the function h of x, which is f of g of x. Part B is write domain and range of h of x. So let's begin by creating the function f of g of x. It is function of function, right? So when we say f of g of x, in this will be f of, what is g of x? G of x is 1 over x minus 2, right? So that is the meaning. Now when we say f of 1 over x minus 2, it means we'll put x as 1 over x minus 2 in f of x, right? So it becomes 5 over, instead of x, we'll write 1 over x minus 2, and then we have plus 1. Makes sense? Which will give us 5 times x minus 2, multiply both by x minus 2, and we get 1 plus x minus 2, right? So that gives you f of g of x as equal to 5 times x minus 2 in the numerator, and 1 plus x minus 2 is basically x minus 1. So, so that's what you get as f of g of x. Now the second part of this is to write domain and range of h of x. Now this is h of x, right? So how will you write domain and range of this function? So let us take it on the next page to write down the domain and range of this function. 5 times x minus 2 divided by x minus 1, right? 5 times x minus 2 divided by x minus 1. So clearly from here, you do see that x cannot be equal to 1. Right? However, there is one more constraint on this. Since we are talking about f of g of x, and you see there's a restriction on g of x, g of x cannot be 2, right? G of x cannot be 2. So the second restriction will also apply. So x cannot be equal to 1 and x cannot be equal to 2 also, right? Because if you're talking about f of g of x, substituting 2, you'll not be able to find a value for g of x. So here we do have a restriction that it's not equal to 2. So that is important to understand. When you are working on composite function, you have to look into the domain of g of x also in this case. And then after that, whatever function you get, further restriction on domain can happen. Do you understand? So that is how you're going to answer this question. Now look here, let's now find the range. So we got the domain. So the domain is x belongs to real number. X is not equal to 1 and 2, correct? Both the values. Let us now find the range of this function. What is the range of this function? From what is seen here, we can say that the horizontal asymptote for h of x is y equals to 5. So definitely in the range of this particular function, we have one restriction, which is y belongs to real numbers, where y is not equal to 5. But see, we also understand that x is not equal to 2. Now, if x was 2, then what value could we get? Substituting 2, we would have got 0. So that means 0 is also not in the range of this function. You agree? So that is additional thing which we have to carefully look into. So that is how the composite functions are very different from normal functions. You have to look into the values more in details because the restrictions in the inside function causes a restriction in the outside function also. Perfect. So that is how we have to look into such questions. I hope this concept is absolutely clear. I am Anil Kumar. In this video, I'm going to discuss with you solution of a very important question based on test paper of advanced functions. We'll discuss transformations when a logarithmic function is given to us. Question number 9. Write g of x as transformation of f of x and then describe transformations in correct order. f of x is log to the base 3 of x, and g of x is log to the base 3 of 1 over 81x. Let's see, how do we solve this problem? So let's begin with g of x, which is given to us as log to the base 3 of 1 over 81x. Apply the properties of logarithm. So we get log 3 of, so when it is 1 over 81, so we'll get 81 is minus, right? So you're multiplying, you can write log 1 minus log 1 is 0. So if you want, you can write log 1, right? Minus log to the base 3 of 81. Now that's a product rule. That's also negative log of to the base 3 of x. You get the idea. So log of 1 is 0. And here we have log to the base 3 of 81, which could be written as 3 to the power of 4. And we have minus log to the base 3 of x. So that means we have log to the base 3 of x and 4 times log 3 of 3, which is 4, right? So plus 4. Correct. So that becomes the function g of x in terms of f of x. You could write this as f of x is given to you as log to the base 3 of x, right? So you could write this as minus of f of x plus 4. And now you can write down the transformation, right? So transformations are start from left to right. Minus means reflection on the x-axis, right? And translation 4 units up. So I hope that is absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. And in this playlist, we have solutions to all the test questions. Explore and learn more from test paper of advanced functions. Let us understand the strategies and enjoy the journey of learning. Question number 10 here is f of x equals to cos x plus square root 3x. Find amplitude, period, and phase shift of f of x. Sketch one cycle of the periodic function f of x. Extremely difficult question. How do we find amplitude, period, and phase shift of this particular function? So the trick to do this is to write this function as r times, we could write sine of x minus alpha or x plus alpha. Then r is going to be the magnitude and alpha is going to be the phase shift. Correct? So that is how we can find amplitude and phase shift for this problem. Now, how do we write this in this form? Now, the expression given to you is cos x plus square root sine x. If you remember, sine of a plus b is what? Sine of a plus b is sine a cos b plus cos a sine b. So you could rewrite the given expression in sine a cos b plus cos a sine b, right? So how do we get this value, right? So what we are going to do is the coefficient of cos x is 1. So let's do one thing here. First, let's begin by writing the equation given to us as cos x plus square root sine 3 sine x. So since we want sine a, so cos b, let's say, is given to us. So let's say, and the cos and sine values cannot be more than 1. So we need to take care of square root 3 also. So what we can do here is both, here it is 1. So what is 1 plus 1 square plus square root 3 square equals to? If we square root that, we get 1 plus 3 square root, and which is equal to 2. So what we can do here is that we can take 2 common and divide these terms by 2. So we get 1 over 2 cos x plus square root 3 over 2 sin x. You see what we did, right? So that is how we could rearrange it. And now we have half cos x and square root 3 over 2 sin x. So we can now write half of this as sin alpha equals to half, right? And cos alpha equals to square root 3 by 2. Sin alpha is half, square root 3 by 2 is cos alpha. I think you've guessed what alpha could be, right? So normally it is not that simple. So what we do is we divide them. So we get tan alpha equals to half by square root 3 by 2. And from there, it is very clear that alpha is equals to, so this is like 1 over square root 3, right? So all this is indicating one thing to us, that we're looking into this particular triangle with sides 1 to square root 3, and sine alpha of half means that angle, which will be pi by 6, right? So pi by 6 becomes the angle. You get the whole idea. So I think now we have understood how do we write this function as a sine function, right? So let's move on to a fresh page and then we'll further work on it. So what we did was we wrote this expression as 2 times half cos x plus square root 3 over 2 sin x, right? And we substituted half to sine alpha and square root 3 by 2 to cos alpha. So, and we got the value of sine alpha and cos alpha also, right? So we wrote the function f of x as equal to 2 times half as sine alpha cos x plus cos alpha sin x, which is the same as 2 times sine of alpha plus x, or we can write x plus alpha, right? And we figure out from here that alpha is equal to pi by 6, right? Therefore, we have the function f of x as 2 times sine of x plus pi by 6. Make sense? So now we can answer what is amplitude, what is period, and what is phase shift. So the amplitude is 2, period is 2 pi, right? And phase shift is left, we can write minus pi by 6, left pi by 6, correct? So that is how we get all the parameters. Now it is a question of sketching this particular sine wave, one wave for this, right? So let's do that part. So we can rewrite our equation, which is f of x equals to 2 times sine of x plus pi by 6. So basically, when you sketch this function, one wave sine starts with minus pi by 6, right? So what you get here is this coordinate point here will be minus pi by 6. The period is 2 pi, right? All the points have shifted pi by 6 to the left, right? So, so this point here is 2 pi minus pi by 6. So 2 pi this point is 11 pi by 6, right? And pi, which is 6 pi by 6, shift one more unit, becomes 5 pi by 6. Makes sense, right? The midpoint, which is 3 pi by 6 or pi by 2 normally, will shift further pi by 6 to the left, right? So you could think like this. Original wave will be like this, right? Correct? Where these points are 0, pi, and 2 pi. Here we have 1, and here we have minus 1, right? This I'm talking about sine x. Now here we have the amplitude, which is 2 here, and this is minus 2. It shifted left, right, by pi by 6. So you get minus pi by 6 here. And this peak, which was at pi by 2, shifts by pi by 6, right? So instead of 3 pi by 6, it becomes 2 pi by 6. Makes sense? One shift here. And this point, which is, so here it is 1 pi by 2, 2 pi by 2, 3 pi by 2, 3 pi by 2, or 9 pi by 6, now becomes 8 pi by 6. You see that? So that becomes your wave, where we could actually draw y-axis somewhere here, right? And say this is 2 and that is minus 2. Does make sense, right? So we shifted the sine wave left by pi by 6 and sketched it out. Amplitude becoming 2, period is 2 pi. Perfect. Starting from minus pi by 6 to 11 pi by 6 gives us one full wave with a period of 2 pi, right? So that becomes the sketch for the given question. So I hope you understand and appreciate how this should be solved. Feel free to write a comment, share your views. If you need a PDF on our question paper, you can always send an email on the given address. Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel. Here we have a very interesting question based on exponential equations. And you will notice that these equations have infinite solution. The question here is 8 to the power of x is equal to 2 to the power of y minus 3. Solution of the equation is y equals to ax plus b. Find the value of a and b. Very similar, question number 2 is also provided for you to practice. Now let us see how do we solve such questions. So let's rewrite. We are given that 8 to the power of x is equal to 2 to the power of y minus 3. So 8 should be written in 2, right? 2 to the power of 3 is 8. So that we have the same base, right? So 8 is 2 to the power of 3. And then we have power of x, which is equal to 2 to the power of y minus 3. Or you could say that it's 2 to the power of 3x equals to 2 to the power of y minus 3. That means with the same base, the exponent should be equal. And therefore, we get the equation 3x equals to y minus 3. Rearranging in the form y equals to x plus b, we get y equals to 3x plus 3, right? So in this case, we get the value of a as 3 and of b also as equal to 3. Is that clear to you? So that is how we are going to solve such a question. You can follow the same strategy, find the solution for the next one. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. So let us write down the steps which will solve this question number 2 also. We are given 27 to the power of 2x minus y equals to 9 to the power of y minus 3. 27 is 3 cubed, so I could write this as 3 to the power of 3 times 2x minus y, and 9 is 3 square, so 3 square times y minus 3. That gives us the equation. Let's write in a different ink. 3 times 2x minus y equals to 2 times y minus 3. Open the bracket. 6x minus 3y equals to 2y minus 6. Or we can get 2y equals to 6x. Rather, we'll add 3 also to this, right? So we should get, in this particular case, 6x. We'll bring 6 on this side equals to 2y plus 3y. So let me just get these things on the left hand side. So 2y plus 3y is 5y, which is equal to 6x plus 6, or y equals to 6 by 5x plus 6 by 5. Makes sense? So that is what we get in this particular case. And therefore, in this case, a is equal to 6 by 5, which is also equal to b. Perfect. So I hope the steps are absolutely clear. That is how we are going to solve this particular question. We'll understand how do we evaluate logarithms without calculator. So we have two examples here, and the important thing is we need to evaluate these logarithms which are seen with radical signs. I am Anil Kumar. Welcome to my YouTube channel. We have organized playlists for you to practice and master the strategies for solving problems. In this video, let us see how do we solve both these questions. We are going to apply standard techniques to solve. First, copy the question, log to the base 2 of square root of 8. We need to evaluate this. Let it be equal to x. Now write this in exponential form, which will be square root of 8 equals to 2 to the power of x. Same base. Now since we have 2 to the power of x on the right hand side, 8 should be written as power of 2, right? So we can write this as 2 cubed square root equals to 2 to the power of x. Square root is to the power of half. So we have 2 cubed to the power of half equals to 2 to the power of x. Applying the laws of exponents, 2 cubed times half will be 2 to the power of 3 by 2 equals to 2 to the power of x. And now, since we have the same base, x value should be same as 3 by 2, right? So 3 by 2 is equal to x. Clear? So that is the solution. So we get here that this is equal to 3 by 2. The next question here, apply the same strategy. Let's copy the question. Log to the base 3 of cube root of 81. Let it be equal to x. Writing in exponential form, we get cube root of 81 equals to 3 to the power of x. Cube root of 81, 81 is 3 to the power of 4, right? So we get cube root of 3 to the power of 4 equals to 3 to the power of x. Now that means we are writing this as 3 to the power of 4 to the power of 1 over 3, right? Which is 3 to the power of 4 over 3. And that gives you the value 4 over 3 for x, correct? So that means log to the base 3 of cube root of 81 should be 4 over 3, right? So I hope that makes sense, right? So that is how we actually solve such questions. I hope the steps are absolutely clear. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. I am Anil Kumar. Welcome to my YouTube channel. In this video, we'll consider 4 examples to solve trigonometric equations by factoring. We are working in the domain of 0 to 2 pi. Solve equations, provide exact solution, or round to the hundreds. You can use special triangles to find the exact solutions. Otherwise, use calculator to calculate the answers in radians. So the settings of the calculator should be in radians. Let's begin with the very first question, which is cos theta cosecant theta equals to 2 cosecant theta. Let's rewrite the equation. Cos theta cosecant theta equals to 2 cosecant theta. Now at this stage, please do not cancel cosecant theta since that will be a mistake, eliminating few solutions. We'll see it soon. Bring the terms together. So rewrite as cos theta cosecant theta minus 2 cosecant theta equals to 0. Now cosecant theta is common. You can factor cos theta minus 2 equals to 0. So now, using the properties of zero multiplication, we have two solutions here. We can write cosecant theta equals to 0, or we can say cos theta equals to 2. As you know, cos theta cannot be 2, so we have no solution for this one. Cosecant theta equals to 0 also does not have any solution, since you know that the value of cosecant theta is either less than minus 1 or greater than 1. So here also we have no solution. So in this particular example, we do not have any solution for the given equation. Now let us take up the second question, which is 4 sin theta tan theta plus 20 sin theta minus 3 tan theta equals to 15. You can bring the terms together and factor. Correct? In the first two terms, we have 4 sin theta as common. We are left with tan theta plus 4, 5, right? 20 divided by 4 is 5. Now we can take 3 common. We get tan theta plus 5 equals to 0. Now tan theta plus 5 is common, and that gives you 4 sin theta minus 3 equals to 0. So we have solution for tan theta equals to minus 5 or sin theta equals to 3 by 4. Within the domain of 0 to 2 pi, tan theta is minus 5 means you are in quadrant 1, you are in quadrant 2 or 3, right? So we have two solutions here. Minus means we are looking at the quadrant 2 and 4. For sin theta to be positive, we are looking at the quadrants 1 and 2. So we have four solutions within the domain of 0 to 2 pi. Now in each case, we should find the related acute angle alpha and then get the other solutions, right? So for tan theta equals to minus 5, I'll write down tan alpha equals to 5, right? So we'll find the related acute angle in quadrant 1. Setting the calculator in radians, we get shift tan, that gives us tan inverse of 5, and we get 1.373. So I'm going to round this as alpha equals to tan inverse of 5, which is 1.37. So what is going to be theta, which is between 0 to 2 pi? So the two solutions are, one is pi minus alpha, the other one is 2 pi minus alpha, correct? So theta equals to pi minus 1.37 and theta is also equal to 2 pi minus 1.37. Let's see what do we get. So we got pi minus 1.37, that gives us the value of 1.77, and then 2 pi, 2 times pi minus 1.37, and that gives us 4.91. So these are the two answers from the first factor, tan theta plus 5. Now let's find the other two answers from the second factor, which is sin theta is 3 by 4. Now 3 by 4 is positive. We can find angle alpha. So sin theta equals to 3 by 4. So alpha equals to sine inverse of 3 by 4, which is, let's use the calculator once again, shift sine inverse 3 by 4. And that gives us 0.848. I'm going to write this as 0.85. So alpha is 0.85. So the two angles for theta will be one in quadrant 1, which will be 0.85, and the other one will be pi minus 0.85, correct? Or is equal to, let's calculate, pi minus 0.85 gives us 2.29. 2.29. So that is how we get solution of this particular equation. So we have four answers. Theta is equal to 1.77, 4.91, 0.85, and 2.29. Make sense? So that is how we will be answering this particular question. Now let's move on and take up the next question, which is secant square x minus 2 tan square x equals to 0. Secant square x minus 2 tan square x equals to 0. Now 1 plus tan square x is secant square x. We can use that identity, right? So I'll replace secant square x as 1 plus tan square x. minus 2 tan square x. So we are left with 1 minus tan square x equals to 0, or tan square x is equal to 1 means tan x equals to plus minus square root of 1, which is plus minus 1. So in this case, we have 4 different values, plus and minus 1. So the solutions will be pi by 4 is when tan is 1. So we have pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. So we get the value of x as equals to pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Perfect. So I hope you have understood the method of solving it. With that, we have solved 3 questions. Master the strategies to solve trigonometric equations with Anil Kumar. Enjoy the journey of learning. Let us now master the strategies of solving trigonometric equations. We have few equations here, 4 of them, involving double angle. Now, when you simplify these equations, they turn out to be quadratic equations. And based on that, the question here is solve equations, provide exact solution, or round to the hundreds. Since you might have to use the quadratic formula and get a decimal value. Great. So make a note of these 4 important questions from test point of view. We'll take them one by one. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to the universities even with scholarship. Great. Question here is 5 cos 2 theta minus cos theta plus 3 equals to 0 on the domain 0 to 2 pi. So cos 2 theta basically has 3 different formulas, as you know. We'll use cos 2 theta equals to 2 cos square theta minus 1 to write this quadratic equation in cosine. So the equation, which is 5 cos 2 theta minus cos theta plus 3 equals to 0, now becomes 5 times 2 cos square theta minus 1 minus cos theta plus 3 equals to 0. That is 10 cos square theta minus 5 minus cos theta plus 3 equals to 0, or 10 cos square theta minus cos theta minus 2 equals to 0. Now we need to factor this. 10 times 2 minus 2 will be minus 20. We need sum to be minus 1. So 4 and 5 work for us. So we'll write this as 10 cos square theta minus, let's say, 5 cos theta plus 4 cos theta. That gives me minus cos theta minus 2 equals to 0. Factor out 5 cos theta. And that gives you 2 cos theta minus 1 plus, we can factor out 2 from here. So we get 2 cos theta minus 1 equals to 0. Now 2 cos theta minus 1 is common. So we get 5 cos theta plus 2. Correct. So this gives you 2 different factors which should be equal to 0 when multiplied. So using the 0 principle, we can say that 2 cos theta minus 1 equals to 0 means cos theta equals to half. And the other one is 5 cos theta equals to 2. plus 2 equals to 0 means cos theta is minus 2 by 5. Correct. So now, for cos theta equals to half, we'll have two solutions which will be in which quadrant? Well, this should be in quadrant 1 and in 4, right? Since you know cos is positive in these quadrants, you can write down the cos rule. Secondly, for half, we can also use special triangle. We need not use calculator. And the angle is pi by 3. Pi by 3 gives you half. And therefore, we know theta is equal to pi by 3 and this angle, right? Which is 5 pi by 3. So we got these two solutions for one of the factors. Now the other one, theta equals to minus 2 by 5. Now that minus 2 by 5 will be in quadrant 2 and 3. So let's find the angle alpha first, right? So we're going to equate cos alpha equals to 2 by 5, right? And find alpha as equals to cos inverse 2 by 5. Use calculator. Setting should be in radians, right? So we have shift mode, radian setting, right? And now do cos inverse. Shift cos inverse within brackets 2 divided by 5. Bracket close gives me a value 1.159. We need to answer in hundreds, so I'll round it to 1.16, right? So I get 1.16 radians as my answer. So the two values will be what? So we get this theta as equal to pi minus 1.16, and the other value is theta will be pi plus 1.16, correct? So let's find this out. So I'll use a different ink here, red one, to get these two answers. So when I add pi to it, I get 4.30. And when I do pi minus 1.16, I get 1.98. Correct. So as expected, we have got four solutions to this particular equation. So these are the four solutions. So I hope you have understood the strategy of solving trigonometric equations like this. Now, based on this solution, I like you to answer the other three questions. How do we find exact value of cos pi by 8? We are going to use the double angle formula to find this value. You can always pause the video, answer the question. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Also, watch our playlist for many related good questions. Great. Now, we need to figure out what is the exact value of cos pi by 8. We know what is cos of pi by 4. Well, cos pi by 4 is 1 over square root 2. Or we also write this as square root 2 over 2, right? Now, cos pi by 8 we can find by using the double angle formula. Now, let's look into the double angle formula. Cos of 2 theta is equal to 2 cos square theta minus 1. Now, here we can rearrange. We can rewrite this as 2 cos square theta equals to 1 plus cos 2 theta, and then find the value of cos square theta, as half of 1 plus cos 2 theta. And definitely cos theta will in that case equal to square root of 1 plus cos 2 theta over 2. Now, in our case, what we have here is theta is equal to pi by 2 theta is equal to pi by 4. And then we can say theta is pi by 8. You get the idea. Now, pi by 8 is less than 90 of pi by 2, right? So it is in quadrant 1, and therefore we are going to take the positive value. Perfect. So that gives you the background how we are going to find the exact value for cos pi by 8. So it is equal to, so we can rewrite this formula. So we can say cos of pi by 8 is equal to positive value of 1 plus cos of pi by 4 everything over 2 square. Makes sense, right? Where we know the exact value of cos pi by 4, we'll use square root 2 over 2. Perfect. So let's begin on the next page with the formula we have just derived. So we have cos of pi by 8 equals to positive value of square root 1 plus cos of pi by 4 over 2 square root. So that gives us equal to square root of 1 plus square root 2 over 2, everything over 2, right? Taking 2 as a common denominator, we can write this as 4, 2 plus square root 2. And square root 2 of 4 is, as you know, 2. So we get the answer, which is 2 plus square root 2 square. So that becomes the exact value of cos pi by 8. Perfect. I am Anil Kumar. Welcome to my YouTube channel. We have more than 17,000 videos absolutely free for you. We are going to discuss 4 trigonometric equations in this particular video. Also explore the playlist for many more examples of similar kind. You can make a note of these questions, answer, and then look into my suggestions. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting excellent marks and admission to the best universities. So let's begin with the solutions. In these problems, we need to solve and provide exact solution or round to hundreds. Since the domain of solution is from 0 to 2 pi, you should use the calculator with radians as the setting. Question number 1 is 2 cos square theta plus cos theta minus 1 equals to 0. So it's like a quadratic equation, right? So we have 2 cos square theta plus cos theta minus 1 equals to 0. We can factor it, product of minus 2, sum of 1. So let's factor. So we got 2 cos square theta plus 2 cos theta minus cos theta minus 1 equals to 0. Taking 2 cos theta common, we get cos theta plus 1. Taking minus common, we get cos theta plus 1 equals to 0. And now cos theta plus 1 is common. So that gives us 2 cos theta minus 1. So, and that too equal to 0, right? So the cos theta value could be what? From the first factor, cos theta is equal to minus 1. From the other one, cos theta equals to half. Now, within this domain of 0 to 2 pi, as you know, the cosine function is kind of like what? It starts with 1, right? and then goes like this. Right. So when we are looking at -1, there is only one solution, and that is the point. So from 0 to 2 pi, the one of the solutions is pi, right? And that is for -1. So we get one solution, which is we can write theta equals to pi. The other one is half. To get this solution, it is a good practice to sketch right angle triangle, which gives you exact value, right? So we know 1, 2, and square root 3 are the values when this angle here is pi by 3. Now, within 0 to 2 pi, as you can see, there are two solutions, right? And these two solutions are actually in quadrant 1 and in quadrant 4. The angle being pi by 3, right? So these are your solutions. So one is pi by 3 and the other one is 5 pi by 3, correct? So we have two solutions here. So we can write down theta equals to pi by 3 and 5 pi by 3, correct? So we get two different solutions, as you can see, pi by 3 and 5 pi by 3. Perfect. So I hope this strategy is clear for these quadratic type trigonometric equations. Remember your special triangles, and if required, solve with the calculator. Here is the second question, which is, let's copy the question, which is 3 cos square theta minus 1 equals to 0. Rearrange. So we get 3 cos square theta equals to 1, or cos square theta equals to 1 over 3, or cos theta equals to plus minus 1 over 3 square root, correct? So 1 over square root 3 basically. Now for this, what can work? Well, plus and minus means that we are looking for four solutions, right? So let me once again share with you this. Now 1 over square root 3, the special triangles do not really work out. So in this particular case, we need to use the calculator. So let's find the related acute angle. So let me write down cos of alpha, where alpha is the related acute angle equal to 1 over square root 3. So, we want to find shift cos inverse, right? 1 divided by square root 3. So, we found alpha as cos inverse 1 over square root 3, and we got this related acute angle alpha as 0.955. So because it is 0.955, I'll round it to 0.96 since we have to write answers to the hundreds, right? Correct. So we got one angle here, and this angle is the angle alpha, right? Since we have plus and minus, you can see that there are four solutions. So the four solutions can be shown on this particular graph, and therefore let's write down what theta could be, right? So theta is the related acute angle 0.96, and then it is pi minus 0.96, pi plus 0.96, and also 2 pi minus 0.96. You get the idea, right? Correct. So let's do this because shift. So I'm using pi now. Shift pi minus 0.9. Let me use the value 5 and then we'll round it. Okay. So it gives me a value which is equal to. So one is, of course, theta equals to 0.96. The other one is 2.186. I'm rounding to the hundreds. Now we have pi plus 0.9. I'm adding 5, okay? And so what I get here is 4.096. So I'll write this as 4.10. And then we got 2 pi. So 2 times pi minus 0.955 I'm using. And I get 5.328. So 5.33 radians, right? So all these are in radians. So these are the angles in this particular case. I hope you are with me. So we have seen two examples in one. We use the special triangle, and here we use the calculator, rounding our answers to the nearest hundreds. So now here is question number 3 for you. We have similar equations, but this time in sine, right? So bring the terms together, you get 2 sine square theta plus 5 sine theta minus 3 equals to 0. 2 times 3 minus will be minus 6. We need 5. So let's factor. So we get 2 sine square theta plus 6 and 1 works for us, right? So 6 sine theta minus sine theta. That takes care of 5 sine theta, right? And now we are going to take 2 sine theta common in the first two factors, giving us sine theta plus 3 minus common gives us sine theta plus 3 equals to 0. Now sine theta plus 3 is common factor, and we are left with 2 sine theta minus 1 equals to 0. So this gives us sine theta equals to minus 3, and the other one gives us sine theta equals to half. Now sine theta value can be between minus 1 and plus 1, so there is no solution for this one, right? Not valid. But the other one, we can again sketch this particular right triangle, and for half we can see that the angle is pi by 3, right? Perfect. So, and we also know sine is positive in two quadrants, and therefore positive half means we are looking into these two solutions where the, pi by 6, right? Not 3, 6. So we have pi by 6, and this angle here will be 5 pi by 6, correct? Great. So theta is equal to pi by 6 and 5 pi by 6, correct? Pi by 3 is this angle, right? Perfect. So we got the two solutions within the given domain of 0 to 2 pi. The last question here is in tan. We are given 3 tan square theta minus 2 tan theta minus 1 equals to 0. Now again, you can factor this. So we get what? So we get 3 tan square theta. You can write this as minus 3 tan theta plus tan theta minus 1 equals to 0. 3 tan theta is common between the first two factors. You get tan theta minus 1. And here we have tan theta minus 1 equals to 0. Now tan theta minus 1 is a common factor. So we get 3 tan theta plus 1 equals to 0. That gives you tan theta equals to 1 as one solution. Or we get tan theta equals to minus 1 over 3. Now tan theta equals to 1 is there in, we got two values, pi by 4, of course, one of them. And tan theta is positive in quadrant 1 and in 4. So we get two answers. One is pi by 4, the other one is 5 pi by 4. Clear? Correct. So we get this as theta equals to pi by 4 and 5 pi by 4. Now tan theta equals to minus 1 over 3 means we have to use the calculator. So that gives us theta equals to tan inverse of 1 over 3. Rather, we'll actually find the related acute angle and then use the strategy to find the answer. So we'll do shift tan inverse of 1 divided by 3, and in radians we get 0.3217, right? let me write 32, right? Great. So if alpha is 0.32, then what should be the angle theta equals to? So angle theta, which will be in quadrant 2 and 4, should be pi minus 0.32, right? Which we can calculate and equals to 2 pi minus 0.32, correct? You can calculate these answers and then write down. So pi minus 0.32, that gives you a value of 2.82, and 2 pi minus 0.32 gives us 5.96. So these are the three solutions for our equation. I hope you find this solution good enough. Feel free to write your comment, share your views.